Hi, welcome back. So in this next lesson, we're going to be building on the generative tapestry we created in the previous example, except this time we're going to add a little bit of complexity to it. We're going to spice it up by adding a few extra patterns. We're going to talk about probabilities, and also just kind of philosophically, what it is we're doing in these examples, really, other than creating some interesting images. We'll talk about that a little bit more. So let's dive right in. Okay. So what I've done here is I went ahead and I've remixed, right? I had this the previous sketch where we ended up on the last example. I've remixed the project and I've renamed it Generative Tapestry 2. The reason for that is I want you to have access to both versions, kind of the simpler version to practice with, and then the more advanced version we're about to build now. So this is one of the neat things you can do as well on Glitch. You can remix your own projects. So if you want to take something that you've been working on that's kind of interesting, and you want to sort of take it into a different direction, but not necessarily kill the one that you were working on, you can use remix on your own stuff to create variations or experiments and whatnot. Okay. So where we left off here is we had two different patterns, right? They were represented as functions. So we have function 1 and we have pattern 1. Oops, didn't mean to do that. We have pattern 1 and we have pattern 2. And the idea is that each of these functions draws a different line. And we're going to create some more options in a second. Then in draw random pattern, we choose from an array that contains both pattern 1 and pattern 2, because we saw that functions are basically, we can treat them as variables in JavaScript. So we can have arrays of functions. And then using the random function, we can choose at random one of these functions from the array and return that result into a variable, and then just use that variable, right? Because it represents a function, just use it as a regular function. Then in draw, we have nested for loops that draw a grid using x and y, right? And jumping in increments of our grid variable up here. And at each iteration, we save the origin, translate the origin to the corner of that grid position, and then we call our draw random pattern function to do its thing. All right. So the first thing we're going to do is we're going to expand on this idea a little bit, and we're going to add some more variations in the patterns. And I'm going to sort of riff on the same idea as 10print, except instead of only having full diagonal lines, we're going to draw some half diagonal lines just to introduce some breaks and some interesting variation in the pattern. Now, because we've chosen to structure our program like so, where we have separate functions here for our patterns, right? And then we have an array of choices that we can choose from. If we want to add more options, we don't really have any if statements to tweak. What we can do is we can just start to write new functions, right? I'm going to invent, I'm going to come up with pattern 3, let's say. Okay, that's going to be a variation on the theme. It's going to go from the top left corner at 0, 0. Instead of going all the way to the bottom right, it's going to stop in the middle. Okay, so what's the middle? Well, it's grid divided by 2 and grid divided by 2. Okay, that's the middle point of our grid. So now I have this other pattern, right? And what I can do is, if I want to add this as a choice, I'm just going to add it to my array. Okay? So now the choices array has 3 different functions to choose from, right? Pattern 1, pattern 2, and pattern 3. And we can see on the right here in the drawing that it creates, now sometimes I have these like half diagonals. So it's sort of introduced some variations in my canvas. And we can do the same for the other direction. I'm going to create pattern 4. So pattern 4 is going to be, let's see, so we want to have the opposite diagonal, so the forward slash, except only going halfway. So we're going to go from 0 grid, right? This is the one that we have up here, except instead of going to the top right, I'm going to do like I'm doing in pattern 3. I'm going to go to the center. And now I have another possible dashed line in the other direction. Now, if I want this to become a choice, right, from my random choices over here, I do have to add it to my choices array. And just to mix it up a bit, I'm going to change the grid size just to see what that looks like. So now I can have these dashed lines, I can have these full lines. It's the same idea, the same pattern. In each grid cell location, we're choosing between 1 of 4 instead of 1 of 2. And we have an equal chance of picking 1 of the 4 because random is an even distribution. So it's going to randomly choose one or the other and not favor any particular function. Now, before we move on, I want to talk a little bit about an important idea here that I'm going to keep repeating and sort of trying to drive home throughout the course of this semester. Because we're talking about generative processes, and we're going to be focusing a lot of our time on writing code that's going to produce a variation in outputs and really use code as our creative medium. The decisions we make when we structure our code are going to become more important. So in other words, like how we choose to organize our code is going to either open or close some doors to us and make it easier or more difficult to expand. So this particular design here, where I've put these functions inside an array and then use the random function to choose between them, to me anyway, is more flexible than if we just used if statements, for example, right? If I used if statements, I would have to create something just to illustrate my point here, right? If I used if statements and we didn't have the the array of choices, right? We could do something similar by using, again, like we did before. We would create a random number, but then now I would need all these different ifs. I would have to think about, okay, so what is the condition for having chosen pattern equal pattern 1, right? And then maybe this is like a quarter of the time, right? Then I would do chosen pattern. And then maybe I have other ifs in there. I have to define other ranges. Oh, made a typo here. Chosen pattern equals pattern 2. And then I'm going to copy and paste. I'm going to save some time here. I have pattern 4. And chosen pattern. I keep making a typo here how I'm writing it, so I'm gonna. Okay. All right, chosen pattern. So I could have expressed, the same thing I'm doing up here using this code, for example, right? And then using a bunch of if statements. But then if I want to decide, let's say I want to add a 4th pattern, or maybe I don't like this 4 pattern idea, I kind of preferred the 3 pattern version, right? Our ability to create structures and code structures that are flexible is going to become a lot more important when we talk about generative art. If I decide to, I'm not interested in pattern 4 anymore, well, now there's like a chunk of the time when no pattern is assigned because this is only 25%, 25. So now I have to account for that remaining. I have to maybe like rejig these ranges and so forth. So this is not very expressive. This is not very flexible. I've kind of painted myself in a corner a little bit here. So one of the things I'm going to try to emphasize throughout these lessons is places where some of the code design decisions really open up doors versus some other ways we could have achieved the same thing, right? Functionally, this is the same, but it's more limited in terms of building on it. Right? I could just, instead of doing this, right, we can just say pick a pattern from this random bag of patterns and then draw that pattern. Okay? This is much simpler, and it's also more powerful because now I can just decide, I can just take out pattern 1 altogether, let's say, from the choices, and really start to massage and sculpt and play with my generative system, and not have too many barriers in the way that are based on my design choices. And obviously you learn these things by coding and by writing software and then making errors and trial and error and finding out things that work better. But that's going to be a big emphasis of these lessons, is really try to figure out ways that we can code better, and as a result, be more flexible and be more creative in the end. Okay, so end of the parentheses here on the kind of the philosophy for this course. But if you're you can expect more of this as we go along, and hopefully you can apply these to other things. This specific example is just one thing that we can play with, create this random image. But the concept of creating flexible code structures, it really applies to anything. All right. Okay, so now that we have 4 patterns in our random selection, we're going to build on this a little bit, and then this is probably as far as we're going to take it for this week. We're going to expand on our use of arrays here a little bit. I'm going to also show you some new syntax that is specific to JavaScript. And what we're going to do is we're going to add some probability, the concept of probability, to our program, meaning that we're going to be able to have different weights for these patterns. We can say maybe like pattern 1 is going to be picked half the time, and then the other 3 patterns are going to be picked less frequently, and that's going to dramatically alter the composition, right? The way that this composition is going to look like. And then we can really start to sculpt this generative program and make it our own. Okay, so how are we going to do this? Well, there's many different ways we could achieve this idea. The way I chose to implement it in this example is we're going to think of this as like we're having a raffle. Okay, and each pattern is going to have a different number of raffle tickets. Okay? So if we want a pattern to win more often, right, or to get picked more often, we're just going to assign more raffle tickets to that pattern. Okay? And let's see how we can implement this in JavaScript. So instead of just having a single array of choices here, we're going to make this array a little bit more complex. We're going to create a 2-dimensional array, which means inside the array, actually it's not even going to be a 2-dimensional array, it's going to be an array of arrays. Small difference. And we can do this very easily with JavaScript. We can say the actual elements of this array are going to be some smaller little arrays. Okay, so if we wanted to say, maybe we're going to give pattern 1, 1 raffle ticket. Okay? We're going to give pattern 2 3 raffle tickets. We're going to give pattern 3 2 raffle tickets, and then pattern 4 is going to get, I don't know, 5 raffle tickets. All right. So now I've created a structure where I have an array called choices, and inside choices, I have put 4 smaller arrays of 2 elements. The first element in the array is the which function, right, the pattern, and then the second element is a number. It's going to be the number of so-called raffle tickets we're going to assign to this pattern when we do the random selection. So this is interesting because in Java we couldn't do this. Like, I'm actually mixing data types inside the same array, and we can do this with JavaScript. So I have an array that the first element is a function, and then the second element is a number, and that's cool. We can have arrays that mix and match any kind of data types that we want. The only, again, thing we have to be careful about when we're in JavaScript is that because it gives us that freedom, it's our responsibility down the road to remember, okay, like choices, choices bracket 0, 0, right? So the first element of the first array, that's going to be a function, right? that's going to be pattern 1, right? And then choices 0 bracket 1, that's actually a number. That's the number 1. Okay? So it's open-ended. It doesn't enforce restrictions, but it's making it a little bit easier on ourselves to maybe screw up down the road if we try to misuse, use these variables in places where they don't fit or they don't make sense. But I mean, what's the worst that can happen is your code doesn't run, and then you just have to figure out why. So it's not like you're going to burn your computer down, but it's just something to be aware of. Okay, so now we've made an array of arrays, right? So we have an array that contains four smaller arrays. And the reason I've done this is because I wanted to be able to associate a pattern with a probability that this pattern is going to get selected. All right. So now that we have made this data structure, obviously now we cannot just use random choices, because if we just say random choices, what that does is that actually pulls out one of these arrays from the list, right? That contains both the pattern and the number that I've decided is going to be kind of like raffle tickets, the probabilities. So we have to get a little bit fancier with our code here. Okay. So let's think of it this way. So here we're going to create an empty array. I'm going to call it raffle. And this really is going to work just like if you were participating in a raffle for a prize somewhere. We're going to say, make this empty array, and we're going to add as many instances, right, of a function into the array as the number of raffle tickets that it has. Okay? So if pattern 1 only has 1 raffle ticket, then we're going to add it once to this array. If pattern 4 has 5 raffle tickets, then we're going to add pattern 4 5 times to the array raffle. So by the time we're done, we're going to have an array that's going to be full of these patterns, but some of them are going to appear more often than others inside the bag because they had more tickets. Therefore, they're more likely to get chosen by our non-biased, undiscriminating random function. All right. So raffle is going to be just an empty array. Okay? And then what we're going to do is we're going to go through all 4 of our little tiny 2-element arrays here. So there's a few ways we could do this. One is we could create just like a typical counter like we would do normally in processing. So I'm going to define a variable called I, and I'm going to say as long as I is smaller than the number of choices, right, the number of elements I have inside the choices array. And then we could say let the item is going to be choices bracket I. Okay. So I could do it like this. And then I could say, okay, well, what are the number of entries in the raffle for this item? It's going to be element at bracket index 1, right? So if we look up here at our array, item is one of these, right? So at index 1, I have the number of raffle tickets, and at index 0, I have the function itself. Okay? So we're going to say, let's add the function itself to our array raffle. Now in JavaScript, if you have an array, an empty array, something worth pointing out as well, unlike in processing where you have to declare the size of arrays when you create them, in JavaScript you don't have to do that. Arrays can just start empty. They're more like array lists in that regard. So what we can do is we can use a function called push to just add stuff at the end of the array. So I'm going to push item bracket 0 at the end of the array raffle. Okay? So again, item, right? Because I iterate here, I'm using I as my index, and I'm iterating over the number of choices. So I'm going to pull out here which subarray I'm interested in using I. That's going to be item. So item is one of these, right? And item, remember, I'm going to put a little comment here so remember. So item, right, has this format. It has the pattern, and then it has a number, right? So it's a subarray from our choices up here. So we're going to say, okay, the number of entries is item bracket 1, right, index 1. And then the function itself is item bracket 0. And then once we've done this, inside this array here, raffle, right, we're going to have a composition that's going to be, we're going to have one pattern 1, we're going to have 3 pattern 2s, we're going to have 2 pattern 3s, and we're going to have 5 pattern 4s, right, all inside this array. So now we can say chosen pattern equals random raffle, right? So go in the bag where we put all of our entries and choose an item at random. So let's tweak the numbers here a little bit just to really demonstrate how this is working. I'm going to really skew towards one and not the other. Oh, sorry, I forgot something kind of important. So here we had the number of entries, okay, but I only pushed the pattern once onto the array. So in effect, that wasn't true. We did not have a probabilistic composition. We just had one of each. Okay? So what we're going to do is we want to say, take this function, okay, and we want to push it on top of the array based on number of entries. So we're going to write another little for loop to allow us to do this. So I is already taken up here. So we're going to call this one J, and we'll say J is going to repeat. Oops, J. Okay. So J is going to repeat, right, based on number of entries in increments of 1. So if we had 4 entries, this for loop is going to add the function, which is item bracket 0, right, the pattern, is going to add it 4 times. If we had 1 entry, it's going to add it once. If we had 5 entries, it's going to add it 5 times. So now we can see the result is actually doing more what I expected. So for example, if we put them all, set them all to 1, okay, and we said, you know, pattern 1 to 20. Now pattern 1 is really dominating this raffle because pattern 1 has 20 tickets, right? So it gets picked a lot, but then there's still a small chance that these other 4 patterns are going to get picked as well. So now we've created a probability, right? Different weight system that we can play with, and we can start to just tweak the design to make it, you know, maybe more interesting or just get different results, right? So for example, we could favor the full lines, but just have less of a chance of having the half lines, so they just happen some of the time. Or we could do the opposite. Maybe the half lines are going to happen quite a bit more. So every time we do this, we're really changing the composition and yeah, just kind of creating different designs. Okay, so let's go over this one more time here. So we start with an empty array. Then here we iterate through the choices array, right, which is this array over here, which contains 4 smaller arrays that have 2 elements. At each iteration of the loop, we grab these elements. I'm calling them items. And an item is a small array with a pattern and a number. The number of entries, right, is index 1, and then the function itself is index 0. So based on the number of entries, I use a for loop to add the function, right, a certain number of times into the raffle bag. And then once we're finished doing this, our raffle list is going to be filled with functions based on these proportions that we selected over here. So now we can just randomly pick one from the bag, and then we can get, even though random is not biased, this list is biased, right? This list has more of, in this case, you know, pattern 3 and 4 than it has pattern 1 and 2. So therefore, it's more likely to get picked. All right. Now, a little bit of bonus content before we wrap up. Just like in Java, if we're iterating over arrays, we also have some kind of convenience for loop type syntax that we can use to make the code a little bit simpler. So we don't always have to use this model where we create an index to count and then use the index to pull out elements from the array inside the for loop. So another way we could rewrite these lines here, these two lines, is like this. So we could get rid of that line altogether. And in here, we're going to say for item of choices. So this is a nice little bit of syntax we can do in JavaScript. It says, because if choices is an array, right, we want to just iterate over all the items inside this array one at a time. And inside the for loop, we can just refer to the variable as item. So this is a shortcut syntax. We'll see there's like different variations of shortcuts as well. But this one here, the keyword of here is important. So for item of choices, right, then inside the for loop, we get access to each of these elements, right? Each of these subarrays, it's called item inside the for loop, and then it will iterate through the array for us. The other little final tweak we could do here to this program, you'll notice if we change like the grid size, the lines become pretty sparse. So one thing that could be interesting to think about is also have like other elements of our drawing tied to our grid size. So here I have one variable controlling the grid size. I could also use that same variable to derive a stroke weight, for example. So maybe we'll say like grid divided by 5. So that if we have bigger grid elements, our stroke is going to be bigger, right? And if we have smaller grid elements, the stroke is going to get smaller. And then we can really like play around with creating some more interesting patterns this way. Again, this is like not something that it would have to do, just something interesting to think about. This variable controls the size of the grid, and we can also tie it to other elements of our drawing, in this case, the stroke weight, for instance. Okay, so that's it for the tutorial this week. Now the next thing you have to work on is a little coding exercise. I'll be explaining this in the next video.